All right, here we are at lesson number 5, and I'm going to take a second to talk about the difference between tibbles and data frames. So we already know what a data frame is. It's a data set. And some of the instructors at Carmel will make use of something called a tibble. And what is a tibble? Well, a tibble is really just a reimagined data frame, sort of a modern version of a data frame that overcomes some of the issues that some of the people at RStudio don't really love, and so they've created this concept of a tibble and created some functions in RStudio that allow you to create them and use them and so on. So I want to introduce you to them. So do you remember earlier when I said we're going to go use these buttons up here to import data sets? Well, I said let's start and just use base R to import a text file, a CSV file. Well, there's this other option here that says you can import a text file, a CSV file, using something called a readr. And what readr is, it's the package that will create a tibble when you import the data. So let's look at what that looks like from the code. So here's our code that we used before, read.csv. I'm going to read in this data set called driving, and I'm going to call this data set just my df for my data frame. Okay. Now I also want to create another version of that data set, but this time instead of it being a data frame, I'm going to create a tibble. So this is the code version of these buttons up here where we import the data set using readr. So you can see I'm using the readr package. You have to have that package installed on your machine. But again, remember with this code, it doesn't have to be active, but pacman pload will make that active. So I'm going to use this function here, read underscore CSV. So a very similar name, read.csv versus read underscore CSV. But what happens is I create a tibble. Now, in terms of how it looks up here, you don't really see much of a difference in your environment space. You've got my data frame and my tibble, but you will see it appear differently as you start to use it. So now, even though you don't see a difference up here in your environment, you can see down here that when you read in a tibble, it actually tells you about how those different variables were read in. And now we'll see some of the different actions that look different between a tibble and a data frame. So, you may need to do some adjusting here to see the same things that I'm going to see here, but this will illustrate what's going to happen here. So if we look at my df and I just go to print that, what you'll see is when you go to print my df that your data frame basically will print to the edge of the window and then it'll start wrapping. So you get this sort of ugly behavior when you go to print a data frame. And a tibble, on the other hand, prints really nicely, even in a smaller window. What it'll do is it'll just fit however much data it can to that window. So you'll see that it prints the variables that fit. There's no wrapping, so you can see this is a tibble. It lists the variable names, tells me what type they are, and there's no wrapping, and it even tells me what variables were left off here from that printing action. So that's one nice aspect that people really like about it. Another thing that it does, which is a little bit more nuanced, but can affect the kinds of things that you're trying to do, is it does something called preserving the original structure. So what does that mean? Well, let's take a look at this line of code here. What am I doing? I'm saying, well, go into my df and get all of the rows and column number 3. So I'm just going to grab a single column from df. And when I grab that single column of df and I say, hey, R, tell me what that one column looks like now that I've grabbed it, well, it originally was a data frame, but now it just returns a single vector of data here. A tibble, on the other hand, will behave differently. So this is the same line of code. It says go into my tibble, grab all the rows, and get a single column. And I'm going to put it in this object I call one column of a tibble. Okay, and so when I run that line of code, you'll notice that in my environment, my column for the data frame is down here, but my column for the tibble is up here. And the reason why is that that single column from the tibble keeps its original structure. It's still seen by R as having this data frame structure of columns and rows, whereas up here it's turned into a vector when I select it just out of a data frame. And again, this idea of maintaining the original structure is a really attractive one on a number of levels. Now the issue is that that behavior there, even though it's really attractive for a number of reasons, can cause a couple of problems. So one of the problems is it can cause certain functions to break that are thinking that it will be getting a vector instead of a data frame. So here's a great example of that. I'm going to load a package called LSR, it stands for Learning Statistics with R, and I'm going to run a function called the independent samples t-test. So this is just running an independent samples t-test on reaction time as a function of gender. And I'm going to start off and I'm going to use my data frame to run that. And when I run that, I get a little warning message because gender's not a factor right now. Right now, gender is a character data, and I could convert it into factor and that would go away. But I get my normal t-test broken up by male and female and so on, so everything looks good. If I run that same function using my Tibble, it actually breaks and you get this error message that isn't really helpful at all. It says the outcome variable must be numeric. You know, like the outcome variable must be numeric. Well, reaction time 1 is numeric, and that's actually not the problem. The problem is that when I grab reaction time out of my Tibble, I get a data frame back, and this function doesn't know how to deal with that data frame structure because it's expecting a vector here, and it sort of sends you down the wrong rabbit hole of, hey, this is not the right type of data, and says it must be numeric, but it is numeric. It's not the right type of data because it's not a vector anymore, and it's expecting a vector. So the real issue here is that it can cause some functions to break because of that performance, even though that's a really attractive behavior for a number of reasons. So I tend to shy away from using readr personally because I don't want it to break certain functions that I use, and especially for new users, they don't know why, and they get sent this strange error message that doesn't make sense. If you are using Tibbles though, and you run into this error message, outcome must be numeric, it's a super easy fix. When you run that same line of code, let me extend this out here. When you run that same line of code, all you need to do is turn your Tibble into a data frame within this one function. So here I'm saying run my independent samples t-test on reaction time as a function of gender. What data set do I want to use? Well, I want to use my Tibble, but I want to use my Tibble as a data frame. So turn it into a data frame, and then it works fine. Again, we get that warning message that we got before, but you can see my t-test results are there, no problem. So again, some of the other instructors might be using a Tibble. There's nothing wrong with that. It has a bunch of attractive properties, but it can possibly interfere with other functions that aren't expecting you to feed it a Tibble and are instead expecting a data frame, and there's the simple fix to resolve that. So this is lesson 6 on selecting variables. Now, we learned a little bit how to select variables in a prior lesson when we learned about square brackets. And what we're going to try and do here is we're going to try and sort of extend the different techniques and tools that we can use to select variables by learning some functions that do some similar things. So to begin, let's clear our workspace. Again, you can do that by sweeping all of the objects away using the broom, so we can just start fresh. Okay, over here I've got lesson 6 syntax file opened up, and we're going to start by using my data. So I'm going to read that in very. Now that I have my data read in, let's talk about a common task that we might want to do. So the common task is we might want to run a function on multiple variables at the same time. So here's an example of what I might want to do. I might want to run summary on all of my Q variables, Q1, Q2, Q3, Q4 that are in my data, to just look at some basic descriptives of that data. And if I run this, notice that I have a comment here that this won't work. So if I run that line of code, I do get some summary information, but I only get it for Q1. So then the question is, well, how could I get that summary data for all the Qs? Well, obviously, I could do each Q individually. I could say, well, give me the summary data for Q1, the summary data for Q2, and so on. But that's obviously going to be a huge pain when we have lots of variables. So what we need is we need a way to refer to a set of variables simultaneously. And we can do this using a bunch of different techniques that will allow us to select out the variables that we want, and then we can apply a function to those variables that we selected out. Now, you already know a technique to do this, and that is the square brackets. So here's an example using the square brackets, which says, well, go into my data, get all of the rows, and get the columns that have these names, and put that in a new object called myQues. Okay, and I'm taking that data and I'm putting it in an object called myQues, but instead of assigning it somewhere, I could have run a function on that, like the summary function. So here on line 32, I'm running a summary function on this same portion of data that basically selects out those variables that I want. And you'll notice that when I do that, I get the summary data for Q1, Q2, Q3, Q4. I could also run the summary function on that single object that I created that just has those 4 variables in it called myQues, like so. And I get the same information. So essentially, line 32 and 35 are exactly the same. And the reason that these two approaches work, but our earlier approach up here, where we listed all of the mydatas don't work, is because of how functions are typically constructed in R. So if we look at the summary function and we look and see how this is constructed just by saying help summary, if we scroll through the list and we say, okay, well, how is the summary function written? Well, regardless of the type of object that we have, basically summary says, I want the summary of an object followed by a comma, and then a bunch of different arguments that allow us to tweak the default options. In this line of code up here, line 18, well, the object that we give it is Q1, and then we have a comma in here, and so R considers these things to be different arguments of that function, and if you look, they don't match up with any of the arguments that R is looking for. So it basically ignores those because they don't make sense to R. What we've essentially done in lines 32 and 35 is we've essentially rewritten this code so that R, when it goes into the summary function, it sees this as a single object, because this line of code takes those different columns and essentially sticks them in a single object. So we can run summary on that single object. And you can see this more clearly in line 35, that summary myQues is a single object, and so summary works, no problem running on that. So this simple illustration of summary is actually something that happens very commonly in R, is that the way functions are structured is they're usually structured to run on a single object, and that single object can be a single column of data. But lots of times we want to run the same function on multiple columns of data over and over again. And so what we need is we need a technique to grab the columns that we want, stick them together so that they operate within the confines of how these functions are written. Okay. So again, we know a way to do this with square brackets. So the remainder of this lesson is really focused on sharing a bunch of common functions that do the same thing. So the first function is actually one you already know, data.frame. So data.frame will actually grab a bunch of variables and stick them in a new data set. Line 52 is a simple example of that. Data.frame, mydata $height, mydata $weight, and mydata $Q4 will grab those 3 columns, stick them in their own data set that we're going to call variables. Now, if we look at variables, you can see that it's constructed just like we thought. One of the downsides of this approach is now all the variables have mydata appended to it, which may be a downside, especially from a typing perspective. So you may not like that. There's also a downside with this approach in that you have to repeat mydata every time as we're writing this line of code, which is really inconvenient. So I want to teach you a shortcut to refer to variables within the same data frame, and that's actually a new function called with. So the way that with works is it lets you perform an action on the same data frame without having to repeat the name of that data frame. So the format of with is, so I'm going to say with, what data frame do I want? Well, I want my data. What's the action that I want to perform? Well, I want to make a data frame out of those three variables. And so now if we look and see how variables is constructed, we can see it's constructed in the same way, but it doesn't append my data here, and it certainly makes us much more efficient here in that we only have to type my data a single time, no matter how many variables we're trying to stick together. Once I put those different height, weight, Q4 into variables, I can run summary on variables. If I didn't want to create that intermediate variables object, I could have done that with this line of code and gotten the exact same thing. Yeah. So data.frame is one function that you're already familiar with that does this selecting out of variables that will allow us to run functions on it. An alternative to data.frame that you'll encounter a lot if you're searching help menus and other information on the web related to R when you're trying to do something is a function called subset. So subset is part of base R, and subset does the exact same thing as data frame, but it has a couple efficiencies built in. So the way subset works is the function's called subset. The first argument is the data frame that you want to use, and then the second argument is select, and it basically says, well, tell me what variables you want to select out. So one of the advantages of subset is you don't have to list all of the variables, but you can use some of these operators that we've already seen, like the colon operator, which says, well, go from Q1 to Q4, and it'll get all the intermediate ones. So this will select out my Qs, which are Q1 to Q4, and it works out fine. Once we have my Qs created, we can ask for a summary of my Qs, and that works again fine. Again, we can do this without actually creating my Qs by nesting the subset function in summary. Again, I tend to discourage this for new users because it's much harder to troubleshoot this than it is to troubleshoot the first function followed by the second function. But again, as you get to be more advanced, oftentimes you don't want to create those intermediate objects, so that might be a technique that you want to use. Okay. We saw how you could gather adjacent columns. If you want non-adjacent columns where the colon doesn't work, you can just list the names of the columns. Now, note in line 77, one of the differences between data.frame and this is in data.frame you need quotes around the column names, in subset you do not. That's just, again, one of these idiosyncrasies in R where some functions will require quotation marks and others won't. Again, I said that subset is useful because it has some handy-dandy things that allow you to select variables, like I can get Q1 to Q4 without typing them all out. Similarly, I can use this notation except. I can say, hey, I want you to select all the variables except gender, and so I get all the variables that I had before, but I've essentially dropped gender. Okay. So one function, data.frame, another function is subset. There's a third function that is very similar to subset, but it is not part of base R. It actually is in the dplyr package, but it is very popular and also very powerful. So I want to share that with you as well. So again, in order to use this function, we need dplyr installed and active. So that's what line 84 does. So the way that select works in dplyr is the first argument is the data frame. So again, we're going to do my data. And then the remaining arguments are the variables that you want to select. So we can select height, weight, and gender just by listing them all. Just like in subset, we could say, hey, I want to get variables from height to Q1, so using the colon. And you can see that I get height, gender, and Q1. I can select all the variables from my data except Q1, like so. Okay, now you might say, well, why do I want to know select as opposed to subset? Because it seems that they're the same. Well, the real advantage of knowing select is that select has a bunch of helper functions that can be particularly useful to select different portions of your data. So here's a great example. So let's look at line 93. Here I'm going to say select from my data, and I'm going to use a helper function as the next argument. I want to select variables that start with the letter Q. So this function, as you'll see, will essentially select all of the variables that start with the letter Q. So I get Q1, Q2, Q3, Q4 without listing them all. You could imagine a situation where I wanted to select a bunch of Qs and they weren't adjacent. Rather than typing them all out, I can select anyone that starts with the letter Q. Here's another helper function, contains. So this will select all the variables whose names contain the letters E and I. And so you can see that when I do that, I select height and weight. So this, again, is not part of base R, so it's not something that you might encounter as frequently because you do need the dplyr package, but it's super useful because it has these helper functions that can do all sorts of things that subset cannot do that's part of base R. All right, so what do you need to remember from this lesson? So again, the theme of this lesson is selecting variables out. And this is a really important task because oftentimes what you want to do is you want to perform an action, again, often running a function on a bunch of variables. But the way those functions are designed is they're designed to operate on a single object. So you usually can't just feed it the names of the individual variables within that function. Instead, you need a way to grab those multiple variables and stick them together in a single object, and then you can use any of the methods above. They all work. It's totally up to you which one you want to use. I would say pick one and become comfortable with it. I would have said historically that most people use subset, but what we've seen in recent time is that people have sort of migrated to using select, mostly because of the helper function. So if you said, well, which one of these three is perhaps most useful, I'd probably say select. So I might say get familiar with that. However, let me stress that that earlier lesson that we had on using square brackets is still critically important because some of the techniques with square brackets that you can use can be adapted for all sorts of things. So even if that's not your preferred method here of just grabbing a couple variables, you still need to be familiar with it. Once you grab those variables, you can put them in an object, often their own data frame, and perform whatever action you want on that new object that you created. In the last lesson, we talked about selecting variables out of a data set. So we're essentially selecting columns out of a data set. In this lesson, we are going to talk about selecting rows from our data set or cases. So we are on lesson 7, selecting cases. Let's start with a clean working environment. So again, use this broom right here to sweep away any of the files that you have created from prior lessons so we can start fresh. So the format of this lesson really duplicates the last one from the standpoint of, we already know a technique for selecting cases from a data set using square bracket notation. So we're going to start off with a very quick review of that approach. Then we are going to talk about some functions that do the same thing. So let's start by reading in some data. Again, we can use my data. Line 12 will read that into your workspace. And if we go down to line 15, this is essentially a review from lesson 4 about using square bracket notation to select portions of our data set. So again, let's break down what line 15 is doing. It's saying, well, go into my data and go to the column in my data called gender and test to see if that's male. And go into the column of my data and check to see the height and see if it's greater than 66. So this portion of the code is essentially a true-false test. So it's going to go into each row of our data set and see if this is true and this is true. If both of those are true, it will return a true, otherwise it will return a false. So you can see it's essentially creating this vector of false, false, true, false, true. Okay, so subject number 3 and subject number 5 are two people that are both male and tall. Notice that I have a comma here because what comes before the comma are the rows. So I'm talking about what are the rows like, and then what comes after the comma are the columns. And again, as a reminder, if I don't have anything that follows that comma, that says get all of the columns. So I'm essentially selecting all of the variables, but only the rows that meet this requirement. I'm going to take that and I'm going to stick that into a new object I'm going to call tall male. So if I run that line of code by hitting Control Enter, I now have this new data set with 2 observations and 8 variables, and you can see it's from subject 3 and subject 5. Okay. So once we have done that, once we've sort of pulled that into a new data set, we could essentially do an analysis on that subset of my data. So I can say, hey, give me the mean weight for the tall males. So I say, go into the tall male data set, go to the column called weight, and give me the mean. And if I run that, I get 182.5. Okay. So that's sort of our review of the square bracket approach. Now what I want to do again is talk about some functions that do the same thing. So in the last lesson we learned about a function called subset, and we saw that subset can select variables out of a data set. Well, subset can also select rows out of a data set, but the format of the subset function is just a little bit different. When you're using subset to select rows, well, you start with the name of the function subset, you specify my data, and then after the comma, when you were selecting columns, you said select. When we're selecting rows, we say subset and say, well, what do I want my subset to be? Well, I want my subset to be males. So again, here's this logical operator for males, and if I run that, you can see that I now have a male data set with 3 observations that consists of all of the males from my data. Okay. Now, we saw how subset worked. It's part of base R, and because it's part of base R, again, you'll encounter it a lot when people are talking about selecting rows or columns. But there is again, sort of a new, somewhat more popular way to do it, but it's not part of base R, but again, it's part of this dplyr package, and it's a function called filter. So in order to use filter, you need to have dplyr loaded. And to use filter, how does it work? Well, the name of the function's filter. The first argument is the name of the data set, and then the second argument is the logical test that you want to use. So in this case, I want to select out the females, and I can do that like so. And so here's my female data set with the 2 females in it. Now, once I have gone in and selected out these different subsets, I can run functions on those different subsets. So I could run a summary on all my data, Q1. I could run a summary on just the males, Q1. I could run a summary on just the tall males, Q1, and so on. Okay. Just like with the last lesson, to do these analyses, what I'm doing is I'm creating these intermediate data sets, female, male, tall male, and so on. But I don't have to do that. I could run my function directly on the line of code that created that, and it would work. So here's an example of how I might do that with the square bracket approach. Here's an example of how I might do that with subset, and so on. So again, the advantage of lines 42 and 44 are that it doesn't create this extra object that could clutter your workspace. So it's really a question of how often you are going to do analyses just with males or just with females, for example. If you're going to do a bunch of those, sometimes it's handy to have that separate data set. If you just need it for a one-time thing, oftentimes it's better to keep a clean workspace and write something like this. Again, the challenge is writing something like this, there's more opportunity for a typo. So it's often nice to first break it up and make sure it works. And then once you know that it works, you can combine the two lines of codes together. Okay, things to remember. Again, you can select cases similar to variables. You can use the square bracket notation to do that. Again, in base R, the really common function that you see people use is subset. But again, remember that it has a slightly different format when you're selecting cases versus columns. And then finally, dplyr has its own way to select variables called filter. I tend to use the square bracket notation because unlike when you're selecting variables, we saw when we were selecting variables in the prior lesson that there were a lot of advantages to these sort of function approaches to selecting variables, like the helper functions or using the colon or something like that. In terms of selecting cases, there aren't a ton of advantages over the square bracket notation. So it's not as if the square bracket notation makes it much harder to use it. So that's what I tend to default to. However, what I would say is filter becomes really useful when you're using it in combination with other dplyr functions. So when you want to select some rows and some variables and do some other sort of data manipulation stuff to get exactly what you want, filter can become particularly useful. So that's another reason why I shared it. But that's it in terms of selecting cases. Again, I don't think there's really much new material here, given that the square brackets are so useful for this purpose. But again, there are some functions that do the same thing, and you may find that you prefer one of those functions, and that is totally fine. So this is lesson 8. In this lesson, we are going to learn a little bit about a lot of things. We're going to talk a little bit about computing variables, recoding variables, and handling missing data. So again, let's start with a clean workspace. You can sweep it away with the broom. And I'm going to use my data to illustrate a couple of these different topics. So let's say if we look at my data, we have Q1 to Q4, and let's say I wanted to compute some total score for those questions. How could I do that? Well, one of the things to remember is to remember that R is a calculator, so you can just use it as a calculator to sum up those items. So remember, when we're referring to the items that we want to sum up, we need to say that Q1 is in my data. The way we do that is we name the data frame $, the name of the variable. So we'd say my data Q1, $Q1 plus my data $Q2 plus my data $Q3 plus my data $Q4. And when I do that, if I run just that one little portion of code, those are my answers, but that answer is just getting printed. And again, it's unlikely you want to print that answer, but you want to save it. The way we save things is we have to assign that somewhere using the assignment operator. So in this instance, I am going to assign that back into my data set, my data, to a new column I'm going to call sum. So if you want to assign something to a new column, you just put a new name there and it will appear automatically. So now if we look at my data, we can see that it's been updated with this new column called sum that is the sum of those items. Now, again, something that's a little bit weird for people is this specification of my data $sum. And the reason you have to do this kind of specification is because of the flexibility of R in that you can assign that anywhere. So notice in line 23, I don't have to assign it back to that data set. I can assign it anywhere. I can make it its own object. So now you can see I have an object here called sum, which is just the values that are calculated from summing those things together. Now, another thing that people notice in this line of code is how inconvenient it is to have to say my data for every single one of those items. And we already know a workaround to that. That would be the with function, right? So how would the with function work? Well, we would say with my data, comma, what do I want to do? Well, I want to add up Q1, Q2, Q3, Q4, and sum those up. And I'm going to put those in a column I'm going to call sum2. So we see that we have now added another column to our data set. So we've got sum and sum2, and they look the same. We probably don't want both of those since they're identical. We can get rid of a variable. This is a new something new for us, I think, which is assigning null to that column. So if I assign null to a column of data, that makes that column of data go away. So again, if we visit my data again, you can see that sum2 has disappeared. All right, so what we just learned is that we can compute all sorts of new variables just like we would with a calculator. We can also leverage functions to do the same thing. So here's an example of the row sums function. So the way the row sum function works is it says, well, I want to get the row sums of whatever I feed it in this next argument. And this is actually a great illustration of why we needed the prior lesson to go in and select out variables. So if we said, hey, I'm just going to copy that line of code and do some quick editing. If we said, hey, I just want to row sum my data $Q1, comma, my data $Q2, this line of code isn't going to work. And the reason it's not going to work is because row sums, when it says, well, what do you want to sum, it needs a single argument to sum up. And we're feeding it multiple things, and it doesn't know how to deal with that. And so right now it's saying, well, you just gave me something, and there's nothing else to sum up there, so I'm throwing an error at you. So in order to use this row sums function, we first need to grab the things that we want to sum and put them together. And that's really what this line of code does. Here I'm using dplyr and select. So you don't need this portion of the code if you have dplyr already loaded and installed and loaded using the library function. But I put this in here just as a reminder that select comes from that package. And again, if you come to this lesson and don't have dplyr already active, then you need that double colon format. But this line of code could look much simpler and slicker, okay? But what does this line of code do? It says, well, go into my data and select these 4 variables. So grab those. And again, what we had done previously with this is we grabbed those 4 variables and stuck them into their own data set. Here what I'm doing is I'm grabbing those and running row sums on them. And when I run row sums, what I want to do, well, I'm going to store the result back in my data in a column I'm going to call row sums. And if we look at my data, now we have my row sum column there. It matches sum perfectly as you would expect. So basically row sum is a replacement for that calculator function. Obviously, if we had 100 items we wanted to sum up, row sums would be so much more useful because we don't have to list all the items we want to add up. We can just say, we'll go Q1 to Q100. It'll grab all those and sum them up automatically. Another handy dandy function is row means, does essentially the same thing, but instead of summing those 4 columns, it will get the means of those 4 columns. And so you can see that that was added in, appended to our data set over there. Okay. Now, what did we learn? Well, we learned that we can compute variables using a calculator. We can learn that we can compute variables using various functions. We just learned 2 of them. There are all sorts of compute and summary functions we could implement. But the general idea here is we call the function, and then we need to say what we want to run the function on. And in this case, we are running the function on these variables. So we're using what we learned in the previous lesson to select out those variables that we want to run the function on and sort of stick them together into one thing. Okay? All right. Recoding data. So recoding is a lot like compute, where there are a bunch of different functions out there to recode. You know, generally depends on what you're trying to recode, whether there might be one that's particularly useful. So I can't obviously cover all of them, but what I want to do is talk about one of my favorite recoding functions that I think is really versatile, and that is the if-else function. Okay. So the if-else function basically takes 3 arguments to work. So the first argument does some sort of logical test, okay? So you feed it some sort of logical test, and then the second argument says, well, here's what I want you to do if that logical test is true. And the third argument says, here is what I want you to do if that logical test is false. So let's look at an example. So this is the if-else function, and what I've done is I've broken it up onto 3 lines. This is actually a single line of code, but I've broken it up into 3 lines so you can see all the different arguments, okay? So what I'm saying here is I'm saying if-else, the name of the function, and then here's my first argument. This is a logical test. So this is the same logical test we used for tall male to pull out our tall male data set. So this will be true if you're both male and you're tall. My second argument is this is what I want you to do if this is true. So what I want you to do if this is true is type out the word yes. And the third argument is what I want you to do if that's false, and that's type out the word no. Now, I'm not just typing out this word yes and no, though, because I'm assigning that then somewhere. So I'm assigning that back into my data into a column I'm going to call tall male. So what we would anticipate would happen is if this is true, this new variable that we're creating, tall male, will have the word yes. And if it is false, this new variable that we're calling tall male will have the word no. So let's look at my data. And you can see that now we have this new variable, tall male, that has the words yes or no, depending on whether you met these tests of being both male and tall. You can, now again, I said this is very versatile because you can combine this approach with different calculations or functions that you might want to do. So again, here's an example of this. Let's imagine that we wanted to compute the total score like we did above, but now let's say that we wanted to give bonus points to a particular group, let's say males. How would that work? Well, here's if else. Here's my first argument, my logical test. I want to check to see if you're male. So if you are male, here's what I want you to do. I want you to calculate the row sums, just like we did above. But if you're male, you get 5 bonus points. If you're not male, I want you to calculate the sum just like we did above, but do nothing extra. What am I going to do with all of this? Well, I'm going to assign this back into my data to a new column I'm going to call bonus. So this is essentially going to be bonus points for males and not for females. So if I run this function, again, I've got that arrayed out on multiple lines of code, but it's really one single line of code, one single function. And I did that for readability. We can see that I now have this bonus column, and we can see, oh, well, bonus matches up to some here, bonus matches up to some here, but the 3 males that are at the tail end of this data set all have their 5 bonus points, okay? So I essentially did something just like we did originally with if-else, but I implemented it in conjunction with a function or calculation. Okay. You can also use if-else for very complex recoding by nesting different if-else functions together. So let's revisit this line of code and say, well, let's imagine that you have some people who said they were male in your data set, some people who said they were female in their data set, and other people who chose an option prefer not to respond when asked about their gender. And I say, well, what's going to happen in this line of code for those 3 groups? Well, the males will get 5 bonus points, the females won't get any bonus points, and the prefer not to respond also won't get any bonus points. So what we're essentially doing here is we're treating the prefer not to respond as if they said they were female. And we may not want to do that. We may want to do something different if they said prefer not to respond. So this is where you can nest different if-elses together. So here's an example of 2 if-elses nested together. And Real quickly, I'm going to adjust that line of code so you can see that it now has the assignment operator because I have the equal sign. We know that functions the same way, but probably bad form on my part. So line 63, what are we doing? We're doing an if-else, and then here's my first logical test. What do I want to do if you're male? Well, I want you to get 5 bonus points. But then, what do I want you to do if you're not male? Well, if you're not male, I want to do another if-else test. And I want to check and see if you're female. What do I want you to do if you're female? Well, I want to get the sum without the 5 bonus points. And then what do I want you to do if you're not female at this step? Well, I want to put NA in for your total score. So here, if you're male, this happens. If you're female, this happens. And if you're neither male nor female, this happens. So we can again run that, and we can see that the total score matches the bonus, so the males are getting the bonus. We don't have any prefer not to responds in here for gender, but if we did, this sort of nesting of this if-else command would have taken care of that. So again, that's just one recode function. If else, there are other recode functions depending on what you're trying to recode and how you're trying to do it. But if else is a pretty versatile function and useful in lots of different situations. Last topic I want to talk about in this lesson has to do with missing data. And recoding missing data can be tricky. So remember, missing data is considered a capital N and a capital A by R. And let's think about 2 different situations where we might want to recode missing data. So the first one is actually pretty simple and straightforward. Let's imagine that we have a number that represents missing data. So some missing data code that's a number that we want to turn into NA, so R knows that it's an NA value. So the simplest example of this would be some 5-point survey that you give out, strongly agree to strongly disagree, but maybe you give out you give people the option that's the 6 score, which is for not applicable in their response. So what you get back from the survey software is numbers ranging from 1 to 6, but a 6 really means that they said NA to that particular item. So we want to convert that into NA, and we actually already know of some simple tools to do this. So one of them is simply just the assignment operator. So let's create a sort of toy data set for us to play with. So I'm going to create a vector of 1 through 6 for call Q1, a vector of 1 through 6 call Q2. I'm going to put those things together in a data frame that I'm just going to call Q12. So here's our data frame of question 1 and question 2, and we want to turn those 6s into missing data. So we can do that pretty simply using some tools that we already know, the assignment operator and square brackets. So let's look at line 96. It says go into Q12 and check all of Q12 to see if this is true or not. So we're going to look at all of Q12 to see if this is true. So again, let's just run this line of code and you'll see that it basically does these trues and falses. And then anywhere that that's a true, we are going to stick NA in there. So if we run that whole line of code and we look at Q12, you can see that the 6s have now been turned into NAs appropriately. All right. Now, there we turned any 6s anywhere in our data set into NA. Well, what if we had a third column where those 6s actually were meaningful? So we didn't want to treat them as missing data. So I'm going to create a new data frame that had the original Q1, Q2, and now I'm going to add in Q3. And if we look at it, it looks like this. So in this data set, I want to turn these 6s into NA, but I want to leave these 6s alone. So again, how would we do this? Well, you already know the tools and techniques needing to convert this into NA. What you would likely want to do is you want to select out what do I want to convert. So this is using square brackets. It's basically saying go into Q1, 2, 3 and grab the columns Q1 and Q2. Okay. and put them somewhere. So I'm going to put them into a data frame I'm calling only Q1 and Q2. Then I can use, now that I've got the 1s and 2s by themselves, I can use that exact same format that we used above to convert them to NA. And so now my only 1s and 2s have the NAs put in them correctly. And then now that they're correct, I can stick them back into Q1, 2, 3. And where am I going to stick them back in? I'm going to stick them back into these two columns. And so if I stick them back into those two columns and we look at Q1, 2, 3, you see that this column's left alone. That looks good. Okay. All right. So that's one kind of recoding of missing data where you're trying to take some sort of numerical code that represents missingness and convert it. And again, that's pretty simple to do and just sort of reviews some concepts that we learned in earlier lessons, like selecting things with square brackets, using the assignment operator to change values, and so on. Okay. Now, the other thing that we might try and do, though, is we might try and turn those NAs into something. Okay, so to understand why that's a little bit of a challenge, it requires us to understand how R thinks about missing data. So again, let's look at Q1, 2, and it looks like this. Okay. And now let's ask ourselves, well, what do we think is going to happen with this logical test? What does this logical test say? It says go into Q1, 2, go to the column, question 1, and test to see if the value of 1 is in each of those cells of that column. Okay. So if I run that line of code, I get these true because there's a 1 in the first position of that column, then it's false, 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 and then I get an NA because there's an NA in the 6th position, then I get a true at 7, false, 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 and then I get an NA. So that makes some sort of sense. But look what happens when we run that same line of code, but now we ask true or false, is NA in that cell? Well, when we run that, we get NAs everywhere. And this is often puzzling to new users of R because they're saying, well, wait, if I look at that, there's an NA there. Why am I not getting false, 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 true, false, 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 true? And the idea here is that you cannot do this sort of normal logical comparison that you do with numbers or text with NA. Because the way R thinks about NAs is it's nothing, it's the absence of anything, and it's impossible to see if the absence of anything is equal to something, essentially. And so it can't do this kind of test, so it throws it out and basically says NA everywhere. So that means that you can't, if I wanted to turn all the NAs into 6s, I couldn't sort of use the same strategy that I used before because nothing will have changed because nowhere is this true. This is NA everywhere. Nowhere is that true, so nothing ever gets changed. Okay, so first we need to understand that R can't do those kinds of logical comparisons that we would normally do with numbers and text. And then to make this work, we just need to know that R does have some specialized functions that will let you do these logical tests. So one of those specialized functions is is.na. Is that value missing or not, essentially? So if we look at just this portion of code and we run it, we can see that now we don't get a matrix of NAs, but we get, no, that's not NA, that's false, 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 true, false, 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 true. So it sort of lines up. So that now, this line of code will work. It will now convert all the NAs back into the 1s through 6s. Okay. Another real key thing to be aware of when it comes with missing data in R is that if you have missing data, many different functions won't run by default. Okay, so most of the default settings for most functions are if you have a single observation missing, that function won't run by default. So for example, again, let's look at Q1, 2, 3. You can see that I have missing data in column 1. And let's say, well, I want the mean of that column 1 if I run that, I get NA. And again, why is that? Well, again, if we look at the help for the mean function, we can see that the mean function works by saying, hey, what do you want the mean of? So that's what the first argument is. And then there's some other options in here. And one of those options is na.rm equals false. And that is set by default. And so what does this mean? This basically says, should I remove missing data when I do this calculation? And the answer is, by default, no, don't remove missing data by default. So when it goes to compute the mean, and when it goes to compute the mean in this function, and you have missing data, it says, wait a minute, I can't compute the mean because I have missing data, and it warns you of this. A lot of people are thrown off by this behavior, but I actually think it's a really good thing because it forces you to acknowledge the fact that you have missing data in your data set. Then you get to decide what you want to do with it. If you want to ignore it, totally fine. All you have to do is tweak that argument in the mean function by adding this to it. So I'm changing the default from false to true, and now I get the mean, no problem. Okay. The moral of the story here is that if you get an NA result and you don't know why, you probably need to toggle that na.rm function to true, or argument to true within that function. Okay. How can you remove missing data from a data set altogether? Again, there are some handy dandy functions. A very simple one is na-omit. What na-omit does is it essentially does listwise deletion. So here I'm saying go to Q123 and omit all of the missing data. So if I run that, I get this no miss data set. And you can see that the places where I had missing data at 1, 6, 7, and 12, those people are thrown out. And so now that I have them thrown out, I can run mean on my no miss data, no problem, without the default, and it works fine. Now again, the key thing to remember is look that this result doesn't agree with this result, even though they're both the means of Q1. And again, the reason for that is because this result is basically based on listwise deletion, and this result up here is essentially based on pairwise deletion. So you do need to know what you're doing to make sure you're doing what you want in terms of how you want to handle that missing data. All right, so key things to remember. If else, super versatile recoding function. When you're trying to do some sort of logical test around missing data, you need to use a specialized function for that, and is.na is one of those. And to remember that most functions have some sort of argument about how you want to handle missing data, and the default is almost always set to false. So if you have missing data, you'll get an NA thrown at you, and so you need to acknowledge that you have missing data and make a decision about what you want to do about that.